Hi everyone, this is Timothy Young, and this is my AE1601 glider video project. My glider's name is the Doppelganger, and this is a story of loss and rebirth. You'll see what I mean later. Alright, project description and requirements. Design and build a hand-thrown balsa wood glider that can fly at least 20 feet, and create a subsequent video report that documents the design, build, and iteration process. Requirements include: must not be bigger than 16 by 16 inches, must be hand-thrown, must be remain intact for the whole flight, must be mainly balsa wood, but other materials can be used to support and supplement the glider, cannot have a built-in propulsion system, and cannot be remotely thrown. And my glider meets all these requirements, as we'll see later in the PowerPoint. Firstly, let's talk about design features. So for the wings, I wanted to use cambered wings at first because they would assist in generating lift better than straight uncambered wings, but because of the thinness of the balsa wood given to us, it was just hard to manufacture. I gave up on the idea entirely. And so I moved on to reversed tapered wings because these would be great for long flights. I first looked at rounded reverse tapered wings, but they're kind of hard to manufacture evenly, and they result in higher area and lower aspect ratio. Then I looked at straight reverse tapered wings. These are great for long flights, easy to manufacture evenly, and easy to calculate area for. And the cons, none really, except for a loss in stability. Let's move on to dihedral. I knew I wanted to add a low dihedral to the wings by the end of the project, because this makes the glider able to self-correct when experiencing roll, but it's hard to execute on a glider with hot glue, and it's easy to make the wings uneven. This problem is even more, it's amplified even further with a high dihedral, because it'll be very easy to make the wings uneven for pretty much the same effect, so that was out the question. But in the last case scenario, I could just do no dihedral if I ended up not having an even dihedral, because it's easy to execute, but it would just mean that my glider cannot self-correct when experiencing roll. Moving on to adhesives. At my dorm, I do have Scotch tape, and so I was considering just using tape only because it's an easy to acquire resource, but it can be quite flimsy and needs to be readjusted after every test flight and crash, which is quite annoying. Then I considered just using hot glue only because it would make the glider very sturdy and does not need to be readjusted after every test flight, but it makes the glider pretty much permanent. Whatever part I add on is essentially permanent, and it's not available at my dorm. It's at the AMS, which is kind of far from the west. And so I ended up doing a mix of both. I can use hot glue to lock in parts of the glider that need to be sturdy, then use tape to patch up small stability issues like a wobbly vertical fin. But the cons, this adds extra weight using the both of them combined. Moving into all possible gliders and their sizes, I opted to build a giant glider at first with the around these kind of parameters, but I also could have made a medium-sized glider with these parameters, or a mini glider with these parameters, and I would have chose a reverse tapered wing for all of these gliders with using adhesive of tape and hot glue, and probably a low dihedral or even no dihedral. And so here's the potential final design. I ended up using a rounded reverse taper with a 1 foot wingspan and a 15-inch long fuselage. The 1 foot wingspan is because the cardboard, I didn't have enough of it to allow a longer wingspan, and I decided on a rounded taper to increase the stability of this the long fuselage. And so with testing, on the first few tests, it would veer to the left or right too much, and it would usually nosedive down after a few meters. So after messing around with the Play-Doh for a bit on the prototype glider on test 20 to 40, it would still veer a bit, but the nosediving / stalling was pretty much removed by now. And so test 40 plus, while I was testing, after fixing up the Play-Doh, I fixed up the wing placement, increased the length of the wing a bit, and changed around adhesive, fixed around some tape. And after 40 or so tests, it still veers, but it can definitely make it past 20 meters with a good, consistent throw. But then disaster strikes. After I make real balsa wood wings for my 15-inch fuselage, I was so excited that when I left the MRDC to test it out, I threw it just right there, and a comically large gust of wind just blows it to the left and into this ditch next to the MRDC. And so this is where the grave of my OG glider lies. There's no getting this thing back. And so, here we go again. I had to make a new glider from the scraps of the OG glider with these new parameters, and it is more of a fusion between medium-sized and small-sized glider. And now, moving on to the design iterations and impacts and features, because making a new glider was pretty much a big iteration in and of itself, I tried to add a dihedral, but it ended up pretty uneven, and I eventually just gave up because it wouldn't help with lift at all. Or self-correcting roll, so I just ended up having no dihedral. But perhaps if I did have add an even dihedral, it would have helped my glider fly farther. As for wings, originally I had large rounded reverse taper wings on my OG glider, so now on my newly reborn glider, the Doppelganger, I switched to straight reverse tapered wings to reduce the area of the wings, increase the aspect ratio, and also it's easier to calculate the area of a geometric shaped wing. And so here's the actual final design. It's 13 grams and fits in this 16 by 16 inch box. And as you can see, it's mainly balsa wood and no propulsion systems in sight besides my hands. And here are the flight videos. This is a 30-foot flight after the competition, and this is the actual competition flight. And unfortunately only went 19 feet, just shy of the 20. And here's a blooper reel of this one flight that veered straight towards my friend, the cameraman. And so moving on to estimating CG, CL, and CD, for center of gravity, the balance point for my glider was about pretty much behind where the wings ended. It was 4 inches down from the nose and below the quarter chord line. As for coefficient of lift, here are all the numbers I used. After a few test trials, I ended up with 4 meters per second of average velocity and 0.004 area for one wing. Plugging all these in, this gets me 0.33 as my coefficient of lift. As for coefficient of drag, using the previous coefficient of lifts plus the aspect ratio that I had calculated to be 36, I got 0.00107 as my coefficient of drag induced, and so my coefficient of drag total is just double this, so 0.00214. Final thoughts. Firstly, RIP to my original glider. If I had not thrown it when I left the Emirate DC that day, I'm sure he would have done epic during the competition. But anyways, I definitely need to be less scared of breaking the glider and put more force into my throws when I throw, because 19 feet on the first try, I definitely could have gotten 20 if I just threw it a bit harder. And one more holistic thing I realized is that I'm more of a lecture and theory kind of guy. So these kind of projects aren't really my strong suit. I wasn't like super stoked about the project, but the dramatic loss of my first glider and the subsequent scramble to create a new doppelganger was definitely a fun and thrilling experience and made the project a bit more dramatic. And so further improvements, I would definitely want a bigger wingspan, larger horizontal stabilizers, and adding an even dihedral to have self-correcting roll. Here are my references. Okay, bye.